Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 4 on Equivalent Expressions Day 2. Now, obviously, the last lesson was Equivalent Expressions Day 1. And then we looked at how to use the commutative and the associative property to write algebraic expressions that are equivalent to some other expression. Now, I think it bears mentioning, right, or reviewing the idea and how important equivalent expressions are. This idea that you could have two expressions that have the same variables in them, and when you then put in any value of the variable into the two expressions, they end up having the same variable value at the end. So much of what we do in algebra, when we manipulate stuff and we play around with like algebra, what we're really doing is we're just using these properties of real numbers like associative and commutative for multiplication and addition in order to create equivalent expressions. Today, we're going to start and work primarily with using the distributive property to actually write more impressive equivalent expressions. So let's get into that right away in exercise number 1. So let's talk about the distributive property. It's one of the most important properties ever. You've been using it since you learned how to do multi-digit multiplication. But here it goes, right? If I've got three numbers, let's say A, B, and C, and I add two of them together, again, here, B plus C, and I multiply by A, what the distributive property says is I can actually do the multiplication first. I can multiply this part of the sum and this part of the sum, both by A, and then I can add the result. So in other words, order of operations really kind of says, no, you got to do the addition first. It's in parentheses. But the distributive property says, actually, I can multiply both parts of that sum and then add. And the same goes for a subtraction, right? Now, we can check that the distributive property works without getting any variables involved. And that's what we're going to do in exercise number 1. Let's take a look. Calculate the product 2 times 37 in two different ways using the distributive property. In letter A, we're going to do 2 times 30 plus 7. And in letter B, we're going to do 2 times 40 minus 3. All right, right? So what does the distributive property tell us? Well, what it says, let me bring this kind of up to the top, is it says if I've got 2 times 30 plus 7, well, I can first do 2 times 30, I can do 2 times 7, and then I can add them together. Now, as we all know, 2 times 30 is 60. And 2 times 7 is 14, and then 60 plus 14 is 77. On the other hand, I could be kind of sneaky, and instead of doing 2 times 37 as 2 times 30 plus 2 times 7, I can do it as 2 times 40 minus 2 times 3. Now 2 times 40, well, that's 80. 2 times 3, that's 6, and if I do 80 minus 6, that is also, whoops, I don't know how I got 77 over here. That should have been 74. Well, and that's why we check. I'll get 74 as well. Sorry about that, right? So what we can see is that the distributive property allows us to do a product, right, where we might have a sum or a difference within that product by doing the product first and then the sum or the difference second. Now, how is this used then to create equivalent expressions? Let's get into that right away in exercise number 2. All right. The distributive property is oftentimes used to write equivalent algebraic expressions. And in exercise 2, we're going to look at a very simple example of that. Let's take a look. Consider the expression 2 times the quantity x plus 7. Letter A, write an equivalent expression using the distributive property. Show your steps. All right, so the only difference between this and the last problem was in the last problem we had two numbers sitting here. Now we have a variable and a number. But the distributive property still works exactly the same way, right? We can take 2 times x plus 7 and we can distribute that multiplication through, giving us 2 times x plus 2 times 7. And just like before, 2 times x, I'm going to just write it like that, 2x. And 2 times 7, well, that's 14. Now, my claim is that 2x plus 14 and 2 times the quantity x plus 7 are the same expressions. They're equivalent. And if they're equivalent, I can grab any value of x I want, put it in here, put it in here, and I should get the same value. We can test that by literally picking any value of x. Let's do that in letter B, where I supply you with a value of x. Letter B. Test the original expression and the one from A using x equals 3. Show the substitution. All right, well, let's do the original together and then have you evaluate this expression. So I'm just going to take x equals 3. I'm just going to plug it up into that expression and figure out what it gives me as an output. So here we go. The original expression, right? I'll put 3 in for x. Right, now I'll just follow some order of operations. 3 plus 7 is 10, and then 2 times 10 is 20. So that expression, when x is 3, is equal to 20. What I'd like you to do now is pause the video, take x equals 3, plug it into this expression, and see what you get. Take a moment. All right, let's go through it. It's simple enough. All I want to do is take 3 and plug it in here. Now that expression, unlike the first one, says, all right, I want 2 times x, and then I'm going to add 14 at the end. Well, 2 times 3 is equal to 6. And then I've got 6 plus 14, and that's equal to 20. I want you to keep in mind that this doesn't prove that this expression and this expression are equivalent. It doesn't. But what it does is it gives us some verification. And certainly, if these two numbers had been different, it would tell us one of two things. Either that these two expressions aren't equivalent, all right, or we actually botched this process somehow. We did the evaluation incorrectly. Okay. But it's good to know. You can test to see whether two expressions are in fact equivalent. Now, let's take a look at a situation that's a little bit harder, where inside of the parentheses, we don't just have an x, but maybe we have like a 3x or a 5x or something like that within the parentheses itself. Let's see that in the next exercise. Here we go, exercise number 3. Consider the expression 5 times the quantity 3x plus 4. Justify each of the following steps using a property. All right, just to make sure you understand what I'm getting at here. I want you to understand how we can go from here to here, why those two things are equivalent. Now, we don't even need to go to the board for this, right? Because the plain fact is, in this step, if I say 5 times 3x plus 4 is 5 times 3x plus 5 times 4, all I've done is taken each term within this parentheses and I've multiplied by 5. And that's, of course, the distributive property, right? That's just what we've been using so far this lesson. So that's the distributive property. And that's exactly what we did in the last problem. But then, when we're dealing with it at this stage, why is it exactly that I can take that 5 and that 3, group them together like this, and then say that they're 15? What property, I want you to think about this for a second, allows me to take the product of 3 numbers, 5, 3, and x, and decide to group the 5 and the 3 together instead of the 3 and the x? Pause the video for a moment and think about what property that is. Well, that's the associative property. Specifically, the associative property of multiplication, right? We're really saying, okay, I'm gonna group these two together, right? And do that first. So that's associative, and it really is the associative property for multiplication or of multiplication, whatever, all right? And that's critical because often we have to do this in a distributive property problem. Now, there is nothing like practice on these. You want to get good at them, you want to get fast at them, you want to be accurate at them. So let's move on to the next exercise where we do some of that work. Exercise number 4. Rewrite each of these expressions using the distributive property. Show the steps in your manipulation, write all fractions in simplest form. All right, this is great. We're all over the place. We got some addition, some subtraction, some negative numbers, some fractions, we got everything here. So let's take a look at letter A together, right? Then maybe have you do letter B on your own. Okay, so here we go. Right, we've got 3 times 4x plus 7. The distributive property tells me that I can multiply the 4x by 3, and I can multiply the 7 by 3. Now this isn't going to be any issue. 3 times 7 is 21. But over here, right, what I'm really doing is I'm doing 3 times 4 times x, right? I'm doing the associative property there for multiplication. And of course, 3 times 4 is 12. So we get 12x plus 21. All right, simple enough. Now, many of you hopefully will get to a point where you don't write down this step or even this step. You just go, okay, I got 3 times 4x, that's 12x, plus 3 times 7, 21. What I'd like you to do is pause the video for a moment and do letter B, which is very similar to letter A. The only difference is that we've got a subtraction here instead of an addition. Pause the video now and take a moment. All right, well, let's do it. We're going to distribute that 8 through the subtraction. Here we go. Right? So we've got 8 times 3x minus 8 times 2. Just like in the previous one, 8 times 2, that's simple. Nothing much we have to do there. That's going to be minus 16. Here again, technically, we've got 8 times 3 times x. There's my x, which is 24x minus 16. All right. So hopefully you got 24x minus 16 as well. Now, letter C is really no different than A and B, except that we're going to multiply through by a negative number. So let's do that one together so we can just review a little bit about negative numbers. All right. So we've got the negative 2. And we're going to distribute that to the 4x plus 1. So we're going to have negative 2 times 4x plus negative 2 times 1. All right, give a little separation here. Now, let me write out this further step. We have negative 2 times 4 times x. And remember that anytime we have a negative times a positive, we end up getting a negative. So negative 2 times 1 is negative 2. Likewise here, negative 2 times positive 4 is going to be negative 8. Now, let's talk about this a little bit, right? I didn't box this in as my final answer yet, and here's why, all right? There's nothing wrong with this. It's a completely correct answer, negative 8x plus negative 2. But the vast majority of times when you have an expression like this, it won't be left as plus negative 2. It will be rewritten as simply minus positive 2, all right? So it'll be rewritten as negative 8 times x minus 2. And certainly, if this was a multiple choice problem, right? So you're taking some test, right? Multiple choice problem. This is not typically written as a choice, but this is. They wouldn't write them both as choices because they're the same answer. All right, but get used to changing the addition of a negative simply into subtraction. All right, let's look at some on the bottom row. Down here, we've got some more negatives. We've also got some fractions involved. They can be pretty ugly. Now here, we're just multiplying through by 3/2. So I'd like you to pause the video, distribute the multiplication by the 3/2, try to remember how to multiply by a fraction, and see what you get. Pause the video now and take a shot at letter D. All right, let's go through it. Again, no real big deal here. It's just the involvement of fractions that can really kind of start to throw us off. So we're going to multiply 4x by 3/2, and we're going to multiply 10 by 3/2. And remember, the way that I really want to think about something like multiplying 10 by 3/2 is I'm going to multiply 10 by 1/2 and get 5, and then I'm going to multiply that 5 by the 3 and get 15. Likewise here, I'm going to multiply 4 by 1/2 and get 2. Then I'm going to do 3 times 2 and get 6. I just don't want to forget that x. So 6x plus 15. As long as you feel comfortable with how to multiply by fractions, that should be easy. Now, letter E, again here we just have a situation where we're multiplying through by a negative. Pause the video again and try letter E. All right, let's do it. So multiplying through by that negative 4, right, we get negative 4 times negative 5x plus negative 4 times 7. Negative times a negative is a positive 20. A negative 4 times positive 7 is a negative 28. And just like before, I'm going to rewrite that as 20x minus 28. Now, I think I want to just pause for a minute to talk about this one. You may have noticed now that when multiplying through by a negative, you're simply changing the signs of everything, right? So I have a negative 5x, and when I multiply by negative 4, it becomes a positive 20. Then I have a positive 7 that when multiplied by negative 4 becomes a minus 28, right? That addition becomes a subtraction because I'm multiplying through by a negative number. And finally, one last one with a fraction. Why don't you pause the video, try that one. No real difference than letter D, maybe even a bit easier. All right, let's go through it. So I'm going to distribute the multiplication by 1/3. So we're going to get 1/3 times 9x minus 1/3 times 6. 1/3 of 9 is 3. And 1/3 of 6 is 2. So simply 3x minus 2. All right, easy enough. Really, really critical to get good at the distributive property. All right, but there's one last case that we haven't looked at, and we're going to take a look in the last two exercises. So, special case of distribution. Let's take a look at exercise number 5. Consider the expression negative 3 times 5x minus 8. Letter A asks us to rewrite the expression so the difference in the parentheses is a sum instead. Now let's talk about this special case. We saw basically everything we could see in the last exercise except for this particular thing, which was a negative multiplying a subtraction. If you look back at exercise 4, we never had a negative outside of the parentheses and a subtraction inside. And we want to be able to just deal with this without even having to do what we're going to do in letter A, but I want to kind of give you some rationale. So letter A just says, hey, take this difference and rewrite it as a sum instead. Well, that's simple enough, right? We've oftentimes rewritten subtraction as an addition by a negative. In fact, in the last exercise, we kept changing an addition by a negative back into a subtraction of a positive. Here, we're kind of going in the opposite direction. Now, letter A then says, letter B says, use the distributive property on B to simplify the expression. It really should say use the distributive property on A to simplify the expression. All right, so here we go. We're going to take negative 3 and we're going to multiply by 5x plus negative 8. So I'm going to distribute, so I'll get negative 3 times 5 times x plus negative 3 times negative 8. Well, negative 3 times positive 5, negative times a positive is a negative, and then a negative times a negative is a positive. Right? So we get negative 15x plus 24. Now, I'd like you to be able to do this without having to write this down and all of this down by simply just thinking, oh, I've got a negative 3 times a positive 5 is a negative 15x. Then a negative 3 times a negative 8 is a plus 24. When we multiply through by a negative, the sign of everything inside changes. Something that's positive becomes a negative, a subtraction becomes an addition becomes a subtraction, etc. So let's try that in the last exercise. Here we go. Exercise number 6. Use what you learned in exercise number 5 to rewrite each of the following. All right, so let's try to do these actually rather quickly. And let's do letter A together, then we'll have you do B and C on your own. So in letter A, what I want to do is I want to multiply everything through by negative 2. So negative 2 times positive 4 will be a negative 8 times x. But then I really kind of want to think about this as negative 2 times negative 5, which would be a positive 10, right? So that 4x becomes a negative 8, and that, if you will, negative 5 becomes a positive 10. Negative 2 times negative 5, positive 10. Why don't you go ahead and work out the answers to B and C. Pause the video now. All right, let's do it. So in letter B, I've got negative 7 times positive 3x will be negative 21x. And then I've got negative 7 times negative 4, which will be positive 28. All right, likewise, letter C. I'm going to have negative 5 times negative 2x is a positive 10x, and then negative 5 times negative 11 will be a positive 55. All right. And I would say letter C might be the most extreme case, right? I've got a negative multiplying a bunch of things inside of the parentheses, all of which have a negative sign attached to them. And again, you might say, well, there isn't really a negative sign attached to the 11, but I can think of this as negative 2x plus negative 11. And then that negative 5 times negative 11 becomes a plus 55. All right, let's wrap this thing up. Today, all we worked with was the distributive property and how to take a product that's written as a number times typically an algebraic expression, right, and how to distribute that multiplication through the expression so that each term within the expression gets multiplied by whatever number was sitting outside. Again, very important because we're going to work a lot with equivalent expressions, especially when we start to solve equations in the next unit. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.